In today's lesson, we'll be learning about scatterplots. A scatterplot can be used to answer questions about the world around us. The first step when using a scatterplot is to ask a cause and effect question. Our question for today is, how does time affect the number of followers on Instagram? Time would be called the independent variable here, and followers would be called the dependent variable. Step 2 would be to restate the question in the form of a hypothesis. A hypothesis is really just an educated guess. It is a prediction. So if time increases, then number of followers will increase as well. Step 3 would be to develop a procedure to test the hypothesis. This can be accomplished with research, a survey, or an experiment. Number 4 would be to carry out the procedure and collect data. I've decided to conduct research by using the internet. The data in the table of values comes from Shawn Mendes' Instagram account. Months after joining Instagram is in the column on the left, and it is the independent variable. It's going to go on the x-axis. Meanwhile, followers in millions is in the right column. This is the dependent variable, and this would go on the y-axis. We can already see that as time increases, his number of followers increases as well. I've already gone ahead and graphed this table of values as a scatter plot. On the x-axis is months after joining Instagram, and on the y-axis is followers in millions. Step 5 is to analyze and interpret the data. You'll notice that I've added a line of best fit to my scatter plot. A line of best fit is a straight line drawn through your points, as many as you can, or you can have an equal amount of points on either side of this line. This is an approximation. It doesn't have to be perfect. A line of best fit helps us interpolate, extrapolate, and look for outliers. If you recall, interpolating involves making a prediction between what you already know. Let's say I want to know how many followers Shawn Mendes has after 10 months. Using the line of best fit, I can predict that he will have approximately 30 million followers. If you recall, extrapolating involves making a prediction beyond or outside of what you already know. Let's say I want to know how many followers Shawn Mendes has after 30 months. By extending the line of best fit, I can predict that after 30 months, Shawn Mendes will have about 55 million followers. Now, we haven't talked about outliers before, but when you think of outliers, I want you to think of outsiders. Outsiders tend to not belong to a group. Take a look at our green points. Do any of them look out of place? I would say that none of them look out of place. Therefore, there are no outliers. Next, we can describe our scatter plot in terms of type, direction, and strength. Let's begin with type. If you look at your green points, does this resemble a line or does it not resemble a line? Since it does resemble a line, I would say that it is a linear relationship. Next, let's take a look at direction. Positive means your points are generally pointing upwards, and negative means your points are generally pointing downwards. Since your points are generally pointing upwards, this would have a positive direction. None would mean your points are neither pointing upwards nor downwards. Your points would be kind of flat. Lastly, let's take a look at strength. Strength refers to how close your points are to the line of best fit. If they're very close to the line of best fit, they would be strong. The further they are away from the line of best fit, the weaker it would be. Therefore, I would say the relationship is strong here. Step 6 would be to form conclusions based on the data and compare them with the hypothesis. If you remember, our hypothesis was if time increases, then followers increase. Since we did see that in our scatter plot, we can say that our data does support our hypothesis. And this does make logical sense. The longer you're on Instagram, the more followers you should have.